So please ask me once you have gone through all the materials that we have discussed before. Okay, now if you go back to your chapter 2, probability distribution, okay, and this chapter come after your first chapter that will be on the your first chapter is dealing with basic to engineering statistics. Okay, and why do we have to follow with the second topic, that is probability distribution? Okay, and if you can see the message here, okay, the message here is quantifying uncertainty using probability. Okay, why do we have to go through this probability distribution? Now, if you remember what are the things that you have covered from the video material that I have given you last week, okay? So among the things of the learning objective that I wish you to get right after you watch all the 7 videos will be define random experiment, okay? Define the outcome, define the event, define the sample space. And then followed by defining concept of probability and describe the rule of probability. Okay? And the third would be compare the difference between classical and empirical probability. And finally, define and give an example of random variable. Okay? Now, I have given you 7 videos. Okay, some of them are very short. Some of them took about the most, I think, 11 minutes. But I think this video is very helpful in terms of how you can understand the whole materials that you need to understand from chapter 2. Okay. Now, do you have any questions regarding the videos that I asked you to watch before we go further? Okay. If you don't have any questions, I was wondering, are you all with me right now? Okay. Now, there are few questions that I asked you. Okay. I think afterwards I will, for the video assignment, what we call the due date will be before the lecture. That would be lecture on Wednesday before 1:30, because my interest is before I begin the class, I would like to go through to your answer of what you have answered in your what we call from your video watching. Now let us look at few questions that I asked from your video. Okay. Okay, so these are all the questions that I asked you. I think about 6 questions regarding the basic things about probability distribution. Okay, and I will go back to probability distribution after
Hello, doctor.
yes.
I have a question with the attendance question just now.
Yes.
For the question 2, I don't really know what he want to ask.
Question 2, is it?
Yes.
What are the outcomes?
Yeah, even though I answer already, but I'm still not sure what really he want.
Yeah, it's okay. Okay, I will. I'm about to explain actually. Okay, thank you. For RK24, these are the question that I gave you. Okay, just to see how far you understand the materials from the video. because as far as I'm concerned, all the videos I chose for the lecture for the chapter 2 is actually related to your textbook. Okay. So the first questions list the sample space for an experiment of tossing a coin and rolling a die simultaneously once. Means that the activity that you do is simultaneously being done. Means that you have your coins, you have your die. Okay. Your coin and your dice you will roll or you will throw exactly at the same time, but you did it once only, and you are not going to repeat that experiment more than once. What happens if you do such experiment? Okay, now let us look at your answer. Okay, before that, I'll just go through. I will just explain what we call your the possible sample space for that particular experiment. So imagine you have a coin, okay, and then you have your what we call you have your die. Okay, so you have your die. Okay, now you have your die, and you know your die will have maybe you have 2 dots, 1 dots, 3 dots, 4 dots, and so on and so forth. Okay, and you throw this simultaneously. And we know for coins, it is either you have your head or you have the tail. And for die, you can also have 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, or 6 dot. So these are the possibilities that you may have once you throw a die and you toss a coin. Okay. Now, what happens if you throw once? Okay, means that you will have the sample space related to your coins, and the second one will be the sample space for your die. Okay, and if you toss once or throws once, so your sample space will be defined as having your tail as okay. I put it this way. Okay, let's say having said that you have head, okay, you can either having head, you can have your 1 dot or your 2 dot or 3 dot, 4 dot, 5 or 6 dot. So that will be if you are having the head. Now you can also have your tail. Okay, instead of your head, you can have the tail for your coins. And the same outcome for what we call the coin, the dice, sorry. So you may have 1 dot, 2 dot, 3 dot, 4 dot, 5 and 6. So these are the illustration of your sample space for your throwing a coin simultaneously with a die. So you can have either H1, H2, H3, H4, H5, H6. That is, we are assuming having the head for your coins. You may also have the tail for your coins and repeating the outcome for the die. So you may have T1, T2, T3, T4, T5, and T6. So this will be your sample space of this particular experiment. Now, when we say what are the outcomes for an experiment of tossing a coin and rolling a die simultaneously, so look back at your textbook. What is the definition of an outcome? Okay, so if you look at your textbook, An outcome is a possible result of an experiment. So what are the possible results? The possible result, you have 12 of them. Okay? So you could either have the tail or the head or the tail of each of these particular outcomes. So if you wish to say the outcome will be H1, so this will be one outcome. Okay? So you can, since the question asks you what are the outcomes, so you can say H1, H3, T1, T6 are among the outcome. Okay, the outcome of this particular experiment. Now, the third question asks you, so what is the outcome? The outcome is specifically referring to your one of the what we call result of your experiment. So you have 12 sample space. So from these 12 sample space, one of them could be one of your outcome. Okay. So the third question, give an example of an event for the experiment of tossing a coin and rolling a dice simultaneously. Now we are talking about an event right now. Okay, so what is event? So look at your textbook. An event is an outcome. Okay, so an event is an outcome. It reflecting your outcome. And your outcome is reflecting your sample space. Okay, so an event is an outcome or outcomes, plural, of a process, that is activity or experiment, whose probability is being calculated. So means that if we are talking about an event, we are talking about the probability. Okay, so if let's say the event that we are looking for, event is having H1, so the event will be probability of H1. Okay, so this is what we call the event. Okay, so the event will be having H1, and this H1 can be calculated using the probability. Okay, so don't bother about the probability yet. We are trying to understand the concept of this particular sample space, outcome, event, and so on. Now, what is the probability of an event? Probability of an event can be less than 0. I'm not sure the full question for this one. Let's look at the question.
It's a true or false question.
Okay. Probability of an event can be less than 0. True or false? Okay. So if you look at your what we call okay. Now, probability of an event. We know that probability can take a value from 0 until 1. Okay, so this is the probability of an event E. Can take value and it begin from 0, okay, until 1. Means that, can it be less than 0? No. So let's say less than 0 means what? We have negative 0.99. Can we have probability of an event equal to this? No, we cannot. Can we have probability of an event greater than 1? For example, probability of an event E is 1.1. No, it is impossible. Probability can take only from 0 until 1. For example, this could be, let's say, probability of an event E is 0.01. So very small probability. And this can also probability, for example, an event, let's say this is an event 1, this is event 2, is 0.9. So higher probability for event 2, so means that we have high probability for that particular event. So the answer would be false. Okay. Probability of an event that is impossible to occur is So if you are talking about probability of an event that is impossible to occur, so we are talking about this particular what we call okay. So impossible to occur means that you have this. The probability of event E is equal to 0 means that this is impossible to occur. Okay. If you are talking about the probability of an event is equal to 1, P of an event is equal to 1. So this is what we call probability of an event that is certainly will occur. Means that it will definitely occur. Okay. So the value of a random variable is determined by chance for each outcome of a random experiment. So look at the sentence. The value of a random variable. So we are talking about a random variable. Okay. So what is random variable? Do you understand what is a random variable? Let us look afterwards. It's determined by chance for each outcome of a random experiment. So when we are saying about outcome, so we are talking about this one of the outcomes that we have in our sample space. Okay. So the value of the particular random variable, okay, is determined by this particular sample space. Okay. So it is true lah. Okay. Yes. Okay. The answer is yes. Some of the students wrongly answer questions. I think this question 4 and question 6. And this reflects that you don't understand the whole concept of what we call probability. Basic concept of probability. Now, any question for this particular what we call materials class before we begin? Any question?
No for me.
No questions. Okay. Now, let's go further. Okay. What is probability? If you look at your textbook, okay, the first what we call page of your chapter 2 describe about what is probability and few illustration or explanation of the whole things about probability. Okay. Now, where does this probability come from? If you remember again our what we call experiment of measuring the skewers, okay, your x, okay, your x in the previous lecture. I'm really sorry, my OneNote is having a problem. I'm not sure why, because it not I cannot write sharply on the screen. Okay, so pardon me, please. I'm really sorry if my handwriting is so bad. Now, remember our experiment of measuring x, the length, okay, the length of skewer, okay, and the length that we are measuring is in cm, okay, in cm. So this x is actually the thing that we are discussing right now, okay. This particular x is actually following some distribution, okay, some distribution. Okay, and when we say following some distribution type, this particular x will also follow some probability. What we call, from this distribution, we have what we call the probability distribution. What we call probability distribution. Probability distribution. Also types. Okay. Certain probability distribution type. So this x can vary. Okay. As we know, it can be counted, it can be measured. So we are talking about measuring the skewers. So this x is obtained by measuring certain objects. Your eggs also can be counted. Okay, so we can count them. Okay, so for example, when we say counted, we are referring to the frequency, for example. Okay, so this particular x that we are talking about, okay, is the things, is the what we call the main things that we are discussing in chapter 2. Okay, so what is probability? So probability is a numerical description of the chance of an event to occur. Remember, when we say event is referring to the outcome, and it is reflecting to the probability of that particular event to occur in an experiment. Okay, so it can take value from 0 to 1. Now, let us look at the example of 2.1. Okay, if a family has 3 children and assume that a boy is likely as a girl at each birth. Okay, so now we know that we are talking about a family with 3 children. Okay, a family with 3 children means that if you are talking about 3 children, means that the mother need to give birth for 3 times, giving the condition that there will be no twins for each of the birth. Okay, now what is the sample space for the gender of the children in the family? Draw 3 diagrams. Okay, so if we were to illustrate this particular situation into what we call 3 diagram, so we are talking about 3 children in a family. Okay, without having twin or whatsoever for each birth. Okay, so we may say that this is the first child. Okay, and we will have the second child, and we can have the third child. Okay, now for the first child, it can either be girls or boy. Okay, either one will occur. It's either having the first child either as girl or boy. Now, given that the first child is a girl, okay, the second child can also be girl, or the second child can be a boy. Okay, the same goes to the second option. Having said the first children is boy, the second can be boy, or the second can be a girl. Okay, can be a girl. Okay, the same goes to the third child. So if we have the first and second is girl, the third can also girl, or the third can be a boy. Having said the first child is girl, second is boy, third can be girl or can be a boy. The same goes to the third. So it could be girl, it could be boy. It could be girl, it could be boy. Okay. From this particular what we call tree diagram, we can have what we call our sample space. Okay. And our sample space will be denoted in terms of set. So the first will be girl, girl, girl. Second would be girl, boy, girl, boy. Okay. Third will be girl, boy, girl. So this one. And the fourth would be girl, boy, boy. And then beginning with the boy as the first child. So you will have boy, boy, girl. This one. You will have also boy, boy, Oh, what happened to my pen? So boy, 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 and then you will have boy, 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 done, done. So the last one will be boy, girl, boy, or boy, girl, girl. This one and this one. Okay, so you will have your sample space as this one. Okay, so all together you will have how many combination do you have? So you will have 1, 2, 3, 4, 5, 6, 7, 8 combination of gender for a family with 3 children. So you will have your sample space, or if you wish to put it this way, so your S would be okay, G, 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 until the last one would be boy, boy, boy. Okay, so this will be your sample space. Okay, define the event E if event E is having one boy. Okay, so you can say event E as having one boy is from the combination of what? So one boy is this one. One boy is this one, and this one, the last one. Okay, so it would be girl, girl, boy, girl, boy, girl, and then boy, girl, girl. Okay, so this will be your event for this particular event E that you define. Any question here, class? Any question?
Doctor,
Yes.
if the question didn't specific, if the question asked for the event but didn't specific the group, then we just can choose from the sample space, right?
Yes. Can you give example? That will referring to question 2 Roman, right?
Yeah, referring to the question too.
Yeah. Normally, if you are being asked about an event, that event will be given to you. So you need to identify from your listed sample space. Okay, so if you are being asked, okay, let's say define the event F, where event F is having, let's say having 2 boys, okay, in a family. Usually they will give command of what kind of event that are being asked. Okay, so it will be specific and you can easily answer that easily from your given situation. So if your event F is referring to 2 boys in a family, so your F will be, okay, where is the 2 boys that you are looking for? So 2 boys is this one, and this one. Exactly 2 boys. Okay, it will differ. The terms that we use reflect your answer. Okay, we will see the third example afterwards. So if 2 boys means that it could be the first is girl, second boy, third boy, or the first boy, second boy, and the third is girl, or the third combination would be the first is boy, second is girl, and third is boy. So this will be your event F. What if your event FG, for example, event G, okay, let's say event G is at least 2 boys in a family. What does this event G means, class? At least 2 boys in a family means that the
You want to have
list will be 2 boys. And can we have more than 2 boys in a family?
Yes.
Yes. When we say at least 2, means that we can at least have 2 boys, or we can also have 3 boys in the family. So if that is the case, so you look at your what we call sample space, okay? Look for 2 and 3 boys in a family. So if you look at your what we call sample space, 2 boys will be this one, this one, this one, this one. So you have 4 events of having at least 2 boys. So G will be G, B, 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 G, B, 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 and B, G, B. So this will be your event G. Okay. Now we are only talking about the event, the outcome, the sample space of an experiment. Okay. Now, if you don't have any equations for example 2.1, so for the next, if you refer to your textbook, right after example 2.1 is what we call classical probability and empirical probability. So classical probability is actually referring to the probability that is based on the number of events to occur. Okay, as compared to your empirical probability. Okay, empirical probability usually is obtained by performing an experiment. Okay, more or less the definition more or less are the same, but for empirical probability, usually the probability is obtained from an experiment, but for classical probability, it's just depending on the number of events to occur divided by the number of sample space that you have. Okay, so I'm not going to go through that particular classical and empirical because it is very basic. Now let us look at the example 2.2. Okay, example 2.2. If a family has 3 children, find the probability that the 2 of 3 children are born. Okay, now we begin at talking about the probability. Just now we are having the sample space as this one, and we are talking about different types of events that we may have depending on our definition of the event that we wish to have. But now, example 2.2, you need to find the probability. Now, for this particular probability, you need to find the event or the probability of 2 of the 3 children are born. Means that 2 out of 3 children are born. Okay, so if you are talking about 2 boys, okay, so if you are talking about 2 boys, so we are talking about event what? 2 boys in a family, so we are talking about event F, right? Right, class? So we have either the second and the third are boy, or the first and the second are boy, or the first and the third are boy. Okay, now how do we calculate the probability? So example 2.2 is reflecting your classical probability. So classical probability says that if you wish to find the probability of an event, you need to find the probability of that particular event. So let's say the event is F, right, just now. So the event F, the number of event F divided by the number of your total sample space. Okay, so event F, how many? We have 1, 2, 3. So we have 3 out of 8. So this is the probability of having 2 boys in a family of 3 children. Clear, class? Okay, so this is kind of straightforward. Now, example 2.3. Now, example 2.3 is actually reflecting an experiment that involved types of blood for 85 UNIMEP students. If you look to your example 2.3. So example 2.3 is for your empirical probability. Now, empirical probability reflect an experiment. So what is the experiment in this particular example? So you are talking about 85 UNIMAP students, okay? 85 UNIMAP students, okay? Now, what happened is that you will ask these 85 students, ask their blood type, okay? For example, I am the interviewer. I have the list of students, 85 students that I need to ask about their blood types. So what will I do? I will just ask the first students, okay, what is your blood types? Okay, the first student says, okay, A. I'll ask the second students, she says, okay, it's O. And then I'll ask until my 85 students, okay, and I will record the frequency of each blood types. Means that how many students with blood type A, how many students with blood type B, AB, and O. And I will have altogether 85 students. So out of 85 students, there will be distribution of numbers of frequency for each blood types. For example, blood types A, 25 students, B, 15, AB, 15, O, 30, and altogether 85. Now, what is the probability of a person has blood type A? So now we are asking about the probability. Probability of what? Probability of this experiment. Okay, not other experiment. We are talking about this particular experiment. Out of 85 students, what is the probability that students will have type A blood? Okay, so in this case, okay, so you will find probability of blood type A is the number of A, okay, divided by the number of sample or the total frequency. So we have blood A is 25 divided by 85. So this is your probability of a student having a blood type A. Okay. So you can simplify. Okay, you can simplify this become what? 5 over 85 divided by 5, you get 17. Okay, or you can say 5 over 17 is 0.2941. Okay, so this is the probability. You can say the probability using the fraction, or you can say the probability using the decimal point. What about blood type B? Can someone what we call calculate for blood type B? Probability of blood type B is what, class? What is the probability for blood type B?
0.176.
0.176. How do you get this? For blood type B is 15 over 85. So if we simplify this, become 3 over 17. So which is 3 over 17 is 0.1764. Okay, correct. Okay, the same goes to blood type O. So it will be 30 over 85. Okay, so you can get the answer. Now, how do we interpret this? Okay, so this will be the probability of student with blood type A, that is 5 over 17, or probability of a person with blood type A is 0.29. So this is how we answer the question. Probability of a student with blood type B is 0.16 or 3 over 17. The same goes to probability of a student with blood type O is 30 over 85, or it will be 30 over 85 is 0.3529. Now, what can you observe from this particular value, class? Class, what can you observe from this particular probability value if we are looking at the decimal point?
It's double. Huh?
What can we observe from this particular probability value? What can you observe from this probability value?
The probability of getting a student with blood type O is higher than the probability of getting a student with blood type B.
Yes, right. Why is that so? Your friend say the probability of a student with blood type O is higher than blood type B and blood type A. Why is that? Why? Any reason, any specific reason why the probability of blood type O become higher than blood type A and B?
Because there are more students that possess blood type O compared to the rest of the blood types.
Yes, yes. The higher the frequency of a specific event will give higher probability for that particular event. The lower the frequency of a particular event, the lower the probability of that particular event to occur within the experiment. Okay, so if you can see the number of event, okay, the number of event will definitely what we call affect your probability value. Now, exercise 2.1. Okay, two fair dice are thrown. Determine sample space of the experiment. Now, I want you to spend like 2 to 3 minutes, draw your own what we call sample space of your fair dice, two fair dice being thrown. Now, to simplify, why don't you use your tree diagram to help you out with what we call your sample space. Use your tree diagram for this particular exercise. I give you 2 minutes. Okay. Two fair dice are thrown. Determine the sample space of the experiment. Done, class? Okay, done, class? Okay, if let's say I draw it, okay, compare with your drawing. So we have two dice are thrown. So means that you need to imagine that we are talking about a die with 6 different faces, okay? And you have another die with 6 different faces, okay? So there will be a lot of combination if you throw the two dice, okay? And this combination can be simplified if you use your tree diagram. Okay, let's say the first die, okay? First, okay, you will have 6 dots. 1 dot, 2, 3, 4, 5, 6. Having said your first die will get 1 dot. Okay, you have second die, you will have 6 options. Having said that your first die is 1 dot. So your second die, okay, will be 1, 2, 3, 4 until dot 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 6. The same goes to the rest. Okay, so you have 1, 2 dot 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 until 6, 1, 2 until 6, 1, 2 until 6, and then you have 1, 2 until 6. Okay, so let us outline the sample space for each. You can have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. You can repeat this until you get 6, 1, 6, 2, okay, 6, 2 until 6, 6. So altogether, how many combination of sample space do you have, class? And S equal to what? 6 times 6. Is it 6 times 6?
36.
36 outcome, right? So your sample space would be S is equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. You repeat for 2, you repeat for 3, for 4, for 5, and for 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. All together 36. Okay, so that will be your sample space of the experiment. The element of A if the outcome of both dice thrown are showing the same dot. Now, if you are talking about the same dot, okay, so that will be reflecting 1, 1, 2, 2, 3, 3, 4, 4, 6, 6. Okay, so event, let's say event A is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Okay, so that will be your event A. The element of B if the first thrown giving a greater number of dots than the second thrown. Now, you have event B, the first thrown, okay, first is larger than second. Means that for For first drone is larger than the second. This one, no. This one, yes. You have 2, 1. Right. The first drone giving greater number dot than the second drone. So you will have for 3, you will have 3, 1, 3, 2. For 4, you have 4, 1, 4, 2, 4, 3, 5, 1, 5, 2, 5, 3, 5, 4, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5. Is there any more?
No.
No. So how many altogether?
16.
5. So NA, number of event A will be 1, 2, 3, 4, 5, 6. Number of event B will be, is it 16? 1,
Yeah,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Is it 15 or 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15, right? Okay, so these are all the number of events that you have for event A and event B. Now, find the probability of event A and probability of event B. Okay, so for event A, then probability of A is number of A. This is following your empirical, or this is an experiment, so this is also empirical. So the number of the sample space, so A is 6/36. Probability of B is number of B divided by number of sample space, that it will be 15/36. Okay, so that's how we find the probability for an event that we define. Okay, so the definition of the particular event is depending on the preference of your questions. Okay, so far, do you have any question for this particular what we call exercise?
No question.
Any question? No.
No.
Okay, now, what do you need to know about the probability? Okay, so some of the question about this particular probability rules, I have asked you in your attendance questions. Okay, but somehow I think I have to discuss in such a way that you know the overall probability rules that you must know are all these 4. Okay. Now, there are 4 basic probability rules. For any event E, the probability of event E is from 0 until 1. Means that an event E can take a probability value of 0, the least, or the maximum, it can be 1. So you can write as PE is equal to 0, PE is equal to 1. And this is impossible to occur. So this is reflecting in the second rule. Okay, or it can take any value along the what we call the scale from 0 until 1. Okay, it can be here, it can be here, depending on the value given to you or based on the experiment given to you. Now, we know that the probability can take from 0 until 1. Okay, what is the second rule? If an event E cannot occur, okay, event E cannot occur means that it is impossible for event E to occur. So what is the probability? The probability is equal to 0. That's this one. Impossible to occur. Okay. Now the third rule is if an event E is certainly will occur or certain to occur, then the probability of event, this should be, is equal to 1. So certainly the event will occur. No doubt that this particular event will occur. Okay, this can be what we call say as 100%, and this is what we call 0%. Okay. Now, what is the fourth rule? The sum of all the probabilities of all the outcomes in the sample space is equal to 1. Okay. Now, what is this meant? Okay, if we are looking at this particular okay, let's look at the example given in your textbook. It is much easier. If a single die is rolled, okay, example 2.4, okay, if a single die is rolled, okay, you are talking about a die, okay, 1 dot, 2 dot, 3 dot, okay, you roll a die. What is the probability of getting an 8 dot? Okay, we know that dot will be from 0 until 6. So getting an 8 dot out of a die is impossible to occur. So it will be 0. What about probability for example 2.5? Okay, so 2.5, when a single die is rolled, what is the probability of getting a number less than 9? Okay, when you roll a die, what is the probability of getting number less than 9? So if you are talking about less number than 9, so you are referring to what? Okay, we know that the outcome from a die of 6 faces, it will be from 1 until 6. Okay, the event of getting number less than 9 are all including the 1 until the 6. So it will be all the 6 events. Okay, so that will be certainly will occur. All of them will be 6 over 6. That will be 1. So this event will certainly occur. Okay, so how do I get 6 out of 6? We are talking about, if we are talking about 1 dot, we are talking about 1 over 6. If we are talking about 2, it is 1 over 6. 3, it is 1 over 6. The last one, 6 over 6, is 1 over 6. So the potential of the possibility of having all these is the combination of all these particular, what we call a single probability of an outcome. So you will get 6 out of 6. Okay, and from this, knowing that we can have what we call 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, 6 dot. So let's say this is your x, small x is number of dot. Okay, and the probability of this particular x is equal to 1 is 1 over 6, 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 1 over 6. And the summation of all the probability of summation of p x equal to small x is equal to 1. Okay, so one way to know that the given probability, the given what we call experiment is a probability or not, it should fulfill all these particular rules. Okay, so these are the rules of what we call probability. Okay, if one of the rule is not fulfilled, we cannot say that particular event or that particular experiment is a probability. Okay, it's containing a probability. So it should fulfill all the rules. Any question here, class? So that will be all the things that we discussed based on page 43. Okay. Any questions so far, class? Okay, we have half an hour. Now, let's move to the second part. The third part actually is the probability distribution. Now, our discussion will go a bit and bit by bit to what we call the whole idea about probability distribution. Now, I haven't talked much on the X random variable because the things that we have discussed here are all reflecting an experiment. Okay, where this experiment will have what we call sample space, and we can define certain event for that particular experiment, and we can find the probability given by the sample space and the number of events that we are looking for. We can find the probability. Now, 2.3 is what we call the beginning of our serious business about random variable and its probability distribution. Why so? Okay, now we are talking about probability distribution. Now remember, if you look through your textbook at the beginning of chapter 2, okay, you have what we call the learning outcome for chapter 2. Okay, and when we talk about the random variable, it directly discuss the learning outcome of your 4th, 5th, and 6th. Okay, define and give an example of a random variable. Number 5, identify whether a random variable is discrete or continuous. And number 6, define probability distribution of a random variable. Differentiate between binomial and Poisson discrete probability distribution and their application. Now, this particular learning outcome is the one that will be measured in your test and quiz. Okay, so for chapter 2, okay, 2.1, 2.2 is your basic understanding of probability distribution. But for 2.3 is the gist of the probability distribution that we wish to discuss. Okay, what is random variable? Now, remember last time we talked about variable in chapter 1. We talked a lot about variable. Who remember what is variable? Can someone tell me what is variable based on chapter 1 that we have covered before? Last,
The
what is variable?
side of study.
The subject of study is your more or less nearly towards your sample or your population. What is variable? What is variable?
Able to change.
What was that?
Able to be changed.
Able to be changed? Not really. What variable? Variable is your main interest in your experiment, right? So variable is the thing that you wish to measure from your sample. Okay, if your variable is reflecting the length of the skewers, then your variable is the length of skewers. Now that is variable. So x is equal to variable. Okay, last time we say this is reflecting the subject of interest, the interest of our study. Okay, interest of our study. Okay, that is your x. Now, when we say random variable, now it becomes random variable, no longer variable. Okay, and it become random variable. Remember class, when we say about a variable become random, when it happen class? Remember we have our population, okay? And we know that we have limited resources, time, money, workforce and everything. We choose subset of our population to be our sample, right? And the X that we measure is actually reflecting the X that we measure from the population. But the way we choose our sample, okay, it should random, right? We say last time. Why it should random? Just to make sure the X that we choose, the sample that we choose from the subject that we choose from our sample is actually representing our population. Right. So there will be sampling procedure. Okay. Sampling procedure involved. And this sampling procedure, okay, will involve what we call statistical procedure. And this procedure will make sure that our X variable that we measure is what we call random variable. Okay. So this random variable, okay, a variable whose value are determined by chance for each outcome of a random experiment. Means that the value of this particular X to occur is based on the chance of that particular X occurring in that particular experiment. Okay, so this all this it sounds a little bit like too abstract is okay. Okay, afterwards when we go through a specific what we call example, it could be helpful for you to understand the whole thing about random variable. Now, this random variable, as we can see last time, we are talking about skewers. Okay, we are talking about skewer. We also can also have about what we call this one is what we call continuous data, right? Continuous data. And we can also have what we call categorical data. For example, gender, okay? Gender, boy and girl, okay? So we have different types of variable to represent our X, okay? And when we say this, when we have this kind of what we call differentiation, this is why then the discrete random variable came in. Okay, and the second one is what we call continuous random variable. Now, what is the difference between discrete random variable and continuous random variable? A random variable that can assume only a countable number of values, exact value, are all what we call discrete random variable. And continuous random variable is a random variable that takes value at any point along an interval. Means that this one can take any value on the scale. But this one need to be counted. Okay, so discrete random variable and continuous random variable. So this will be asked in your quiz and test. Okay, so you need to understand what is discrete random variable, what is continuous random variables, and what are their examples of each of the random variable. Hold on a second. Hello. Nah, ibu ada kelas ni, kita pergi. Ada apa? Ada apa? Tak apa, itu okay. Esok itu petang cari tadi pun pula. Okay. Okay, ya. Terima kasih. Okay. Now, Let us look at the example 2.2, table 2.2, two types of random variable, discrete random variable and continuous random variable. For example, we may have number of sales, number of calls, number of patients, people in the line, mistakes per page, number of defective items. So if you are talking about number of sales, okay, so if let's say we are talking about number of sales of a handphone, for example, in one day, how many handphones that can be sold, okay? So that would be number of sales. Number of calls received in a day by what we call customer service, for example, okay? So that reflects what we call discrete random variable, means that all the outcome can be counted, okay? We can have 2 sales, 3 sales, 2 phone calls, 3 phone calls, 4 phone calls. Number of questions, we have 4 questions, we have 5 questions. We cannot have a 3.5 question, no. Okay, exactly there will be what we call exact value or exact number for that particular what we call random variable. Mistake per page. For example, if we are counting the mistakes, we are counting the number of mistakes. For example, a typo error. Okay, so how many mistake of typo error in one page? So that is reflecting the counting process that happened. Number of defective, how many defect, how many non-defect. So exactly, it will give you exact value. But for continuous random variable, we have what we call, for example, length, depth. Length, for example, what we have in the skewers project. So we have the length of skewer measured in centimeter. We have depth, maybe in meter. Okay, we have volume, maybe in centimeter cube or meter cube. Time, for example, 2 hours, 3 hours, 2.5 hours, 3 minutes. Okay, so on and so forth. Weight can be 85, 85.5, 80, 50, 50.5, 50.2. Things that need to be measured falls under what we call continuous random variable. So by now, I hope you should differentiate. You should be able to differentiate how to identify what we call discrete random variable and how to identify continuous random variable. Okay. I guess I need to stop here because it's already 10. Okay, before I stop, do you have any question regarding the materials that we have discussed? Class, I think the discrete probability distribution, I will assign few more videos before we can what we call discuss in detail the what we call the content of 2.4 discrete probability distribution as well as 2.5 continuous probability distribution. Okay, so because this will be covered in your test and quiz, I think what we call further details of explanation need to be done in the lecture. Okay, any question before we stop? Any question?
Doctor,
Yeah.
can you also upload this slide in Google Classroom? The yang dah conteng punya.
I can. I last time I always upload my Google what we call my slide in the lecture in the Google Classroom because to make easy for everyone. But your group it's okay lah. I'll upload. My comment I'm afraid my comment will hurt some of you. Those who give your full cooperation, I thank you very much. For those who have not watched those videos that I have assigned, please don't make me very strict, because if I were to be strict, if I say okay by 3 May, 3rd May, everyone should submit all the attendance, then I will just close. Okay. So I really hope everyone can understand the material. So as requested by one of your friends, I will upload the what we call the slide in your Google Classroom afterwards. Along with your video. Okay. Any other questions, class? Any other questions?
No, Doctor, from me.
So yes. Okay, no questions. So if that so I'll just stop before we dismiss. Those who don't have any question regarding your project 1, you can leave the meeting, the online class. Those who have questions, you can remain in the Google Classroom. I mean, in the online class. Danish Kumar, I saw your name. And as far